All right, students, Miss Slyman here for example 2. So now we've got 10 discs, 5 yellow, 3 black, 2 green, 2 selected in succession with the first one not replaced. So basically we're saying that we're going to take it out, look at it, and not put it back in the box. So now our events are dependent, not independent. So probability that the discs are different colors, well, that means that they're all not the same color. So let's look at our tree diagram here. So we've got our first disc that we're going to pick. And if we made our tree diagram, the first disc has one of 3 options. So either it's going to be yellow, black, or green. And we had a few different probabilities for that. We had 5 out of 10, or 1/2, and 3/10 and 2/10. And then we have the same options again. We can have yellow, black, or green, yellow, black, or green. I'm trying to figure out the best way to fit all 3 here. And again, we have 3 options, yellow, black, or green. So in the end, we've got this total of 9 options. And so 2 different colors means I could have yellow, yellow, black, yellow, green, black, yellow, black, green, green, yellow, green, black. Or I can think of it as being 100% minus the probability that I have the same colors, which would be yellow, yellow, black, black, or green, green. So that's 3 options versus 6, so I'm going to calculate those 3. So if I pick 1 yellow and I take it out and don't put it back, that means there's 4 left and there's 9 total. If I pick 1 black, there were 3, so now there's going to be 2 out of 9 total. If I pick green first, that means there's going to be 1 green out of 9 left. So the probability of the same colors, I'm going to have 1 minus yellow, yellow is 5 times 4 out of 10 times 9, because I'm doing 5/10 times 4/9, minus 3 times 2. I said 2 and I meant 2. 3 times 2 over 10 times 9. And the reason that I didn't simplify any of these fractions at the beginning is because now they all have the same denominator. So I don't have to worry about going back and making that common denominator. So I'm going to have 90 out of 90 minus, I've got 20, and then if I'm making one minus sign here for a big fraction, that's got to be a plus. 6 and 2, because I'm subtracting all of those things out of 90. So 26, 28, 90 minus 28 is 62 out of 90 are going to be the probability that I pick different color. Discs that are the same color, well, I already did that. That's my 28 out of 90. Okay. Both were black given the second disc was black. So now, given the second disc is black, that means I'm looking at these options. Here the second disc is black, here, and here. So that's my given probability. That's going to be my denominator. Both were black means this option here, starting black and ending up black. So this top part is my numerator. That's my only way that they're both black given these 3 options on the bottom. So let's write this out. Probability of black, black, given that the second is black. So that's going to be the probability of black, black over the probability that the second is black. So this is the probability of black, black. This is really the probability of black, black intersect second black, but that's the same thing. The probability of black, black is wholly contained within the second one being black. So I'm going to have 3/10 times 2/9. That's going to give me my 6/90 as my numerator. My denominator, well, to get to this one, first I have to go to the 5/10 and then come down to the black. If I've taken away a yellow, there's still 3 blacks. That's 3 out of 9. If I've taken away a green, there's still 3 blacks, 3 out of 9. So my denominator is going to be 5/10 times 3/9, so that's 15/90, plus the option we had, 6/90ths, plus this last option. So to get here, I can't just take 3/9, I have to go to the 2/10 first. So that's also 6/90ths. Notice that the 90ths are all going to cancel, and I'll end up with 6 as my numerator, and in the denominator, 15 plus 11 is 26. So the probability of black, black, given that the second one was black, 6 out of 26 is our probability there. And of course you can reduce all of these fractions, but it's also okay to leave them this way.